All right, so let's get into problem number 2. Once again, we're going to be dealing with problems where the object is being launched horizontally. And I know that I said this for the previous problem as well, but by the wording of this problem, you should be able to conclude that this is the picture that you're going to be referring to as far as the trajectory of the object goes. So you have a steel ball rolls with a constant velocity across the tabletop this many meters high. It rolls off and hits the ground at this. Okay, so once again, let's just get into this where we're going to be pulling out the given information. First thing I want to do is write out the quantities I'll be pulling out. Already we know that the acceleration is due to gravity is negative 9.8 meters per second squared. We already know that. And once again, it says the steel ball rolls with a constant velocity across the top. Okay, so being that's rolling, it's rolling over here, bam, it's going to roll off the table at this certain velocity, at a constant velocity. It doesn't tell us what the constant velocity is, but it does tell us how high the table is. Okay, and what piece of given information would that be? I'm sorry, what quantity would that be? That would be our initial height of the object. And being that's going to be hitting the ground, so it hits the ground, what does that tell you about the final height? And it's going to be 0.352 meters horizontally from the edge of the table. What do you think that that's telling us? Well, it's going to be, so here's where it begins, and it'll go out here. 0.352 meters. So that's telling us the final position in the x direction. 0.352 meters. And the initial position would just be 0. And once again, is the object being initially launched up or thrown downwards at any sort of initial velocity? No. So therefore, what's the initial velocity in the y direction? And the problem's asking us, how fast was the ball rolling? All right, so what's that asking us? That'll be the velocity in the x direction. Does it tell us anything about does it tell us anything about the amount of time or the final velocity in the y direction? No. So once again, those are going to be two pieces of information that we don't care about. Well, we have two pieces. Okay. Well, we can't have three pieces of information that we don't know and that we don't care about. So we do know that we're trying to find this over here, which is the only place that we'll see that in our kinematic formulas is going to be right here. So we know for sure that we're going to be using this equation. And this equation includes both Vx and delta t. So we're going to need to find out what our delta t is equal to in order to be able to find out what Vx is equal to. Okay, so that makes sense. So we're going to have to find out, one, what our delta t is equal to, and then be able to find out what Vx is equal to. Okay. So also, once again, we don't know and we don't care about the final velocity in the y direction. So therefore, once again, all that we're going to do is every single time that we see final velocity in the y direction, let's take that out. We don't care about it. Let's cross it out in our kinematic equations. And once again, it looks like that we're going to be using equation number 4 to find out our delta t. Okay, and just plugging in our given information. And just like before, this term over here is going to equal 0. 0 times any number is equal to 0. All right, and it's just going to be the same process as before, trying to solve this out. Hopefully, I'll give myself enough room to be able to do this. I'm not going to guarantee that, though. And it looks like that I will not be giving myself enough room. All right, I could deal with that. We have our delta t is equal to what? What's this division over here? Once again, we don't care about what delta t squared is equal to. Also, once again, make sure that you're dropping down your squared. That happens a lot. So just make sure that you're keeping track of your squared, and you'll see that delta t is equal to 0.44 seconds. Once again, this is not the quantity that we care about, but we do need it in order to be able to solve it for Vx. So we're just going to, once again, just use that quantity of delta t in for our Vx formula. And there we go. And that's it for this problem.